So again, paper from yesterday, going to go over a couple of the problems. I'm not going over all of them just yet, but go over some of them. Now, for that first page, we're dealing with prisms. I'm going to go over two of these problems with you guys right now. Like I said, I'm not going over all of them just yet. There is a spot to, and there's actually two spots to turn this page in on. Yesterday, I had to only do the surface area part of it. So just these first two pages, pages 12 and 13. And then the volume that's on the back is your assignment for tonight. So just make sure you turn in the correct places. So again, this one, I'm going to go over a couple of problems because some of these were more challenging than others. 5 and 6, you want? Yeah, that's fine. Okay, it doesn't matter which two I do, so. All right. So I had requested to do 5 and 6, so I'm going to do those two. Now, on some of these, again, the biggest thing is identifying what is your base. So just identifying what are our bases in each one of these. Well, on number 2, we have a rectangle. On number 3, it's the pentagon. Now, the work for finding our apothem on number 3 is pretty much the exact same as what we did up there on the example problem. So I'm not doing all of number 3 right now, but just to give you an idea, since they just did a pentagon up there, you can use that work to help you out because essentially the only thing you have to switch out in this entire problem is instead of having a 7.5, which was half of that side that was 15 centimeters, down here where you have 6, half of that side would be 3. So if you just plug 3 in that equation, that's how you get your apothem because it's the same. So we have this equation that they came up with up there. Get rid of this and plug 3 in for that one. So on number 3, we're doing our apothem. Our apothem can be found by doing 3 over tangent of 36. It's the exact same shape as what we had on the top. So if you didn't do this one already because you couldn't find your apothem, just know your apothem on this one is 4.129. Again, I would always recommend keeping a couple extra decimals. So this one said round to the nearest 10th. So you get to the end, keep a few extra decimals. So maybe 3 decimals would be good. But hopefully that helps you finish that one if you haven't already done it. Number 4, you have your trapezoid as your base. So again, putting those values in for your trapezoid. You had to say 5 and 6. So on number 5, let's go ahead and do this one all the way out. Again, you had to do base area, followed by lateral area, followed by surface area. So there's 3 steps here. First, decide which one you want to be the base. When you have a rectangular prism, you actually have options because there are 3 different sets of sides here that are opposite of each other and are both parallel and congruent. So in a rectangular prism, you could actually have these 2 pieces on these ends, these squares. You could call those the bases if you wanted to. Or if you wanted to switch it out and have this part on the bottom be the base, that's fine. But just remember, whatever you call the base, you then have to make sure you identify the correct piece as your height. Your height of your solid will always be the distance between whatever bases you chose. So on here, I'm going to choose the 2 squares as my bases. So for base area, we're going to do 4 times 4, which is 16. Then for lateral area, it's again, perimeter times height. So perimeter of the base, so if all these sides are 4, that's going to be 16 going in for perimeter. And the height of the solid would be 12 if I was using the square as my base. Then I have the 16 times 12, which equals 192. And finally, for my surface area, it's my lateral area plus 2 times my base area. So we have 192 plus 2 times 16, 192 plus 32 is 224. Yeah, these were in inches, so all of these values that I got should be in inches squared. Now, when we go over to number 6, we have a regular hexagon as our base. So we could find our aptum similar to how we did for our figure up at the top of the pentagon. However, when we have a hexagon, if I draw in the aptum here, I'm drawing this piece, there is a special right triangle that was formed. So I'm going to draw this a little bit bigger off to the side. So this being my apothem, if that whole side is 4, this side is 2. And again, this is a special right triangle. This is my 30, 60, 90 when I have a hexagon. So if I know the short leg is 2, the long leg is then 2 radical 3. So that's my apothem on this one. We can plug into our formula right away. So we have, for our base area, 1/2. Again, you can either use 1/2 ASN or 1/2 AP. I'm going to just do 1/2 AP. A on this one, we just found our apothem was 2 radical 3. Our perimeter, each side is 4. There's 6 sides, so 4 times 6 is 24. My perimeter. And multiply it all out. So 1/2 of 2 is just 1. 1 times 24 is 24. If I was leaving this as an exact value, I have 24 radical 3. Again, since all these values, it says it's rounded to near 10. Go ahead and multiply that out. So square root of 3 times 24 is 41. 0.6. And this is a square. All right, that's my base area. Now we also have to find lateral area and surface area. So lateral area. We already know the perimeter of the base was 24 from before. So again, perimeter times height. 24 times the height is going to be 16. 24 times 16 is 384. Do it in the square. Surface area, lateral area, plus 2 times the base area. Or 67.2 meters squared. Again, each of these problems is very similar. It's just changing out whatever the shape of the base is. When we do the base formula, and then the rest is the same. All right, let's do a couple from the cylinder side. Because now on the cylinder side, so now with the cylinders, same base formula every single time. It's the circle, which is pi r squared. So on here, we just do, so you want 5 and 6 again? All right, so 5 and 6. On this one, they gave us the diameter. Well, if the diameter is 12, that means that the radius is 6. I got my radius. That distance between the 2 circles, that's my height. So again, that's my height that means. 4. So base area, pi r squared. So we have pi times 6 squared. That's 36 pi. Again, I recommend leaving everything in terms of pi at first. Then for a lateral area, again, it's circumference times height. Again, we can plug in for circumference 2 pi r. So 2 pi r times height. The radius again is 6, the height is 4. So 2 pi 6 times 4. 2 times 6 is 12. 12 times 4, 48 pi. That's our lateral area, again in meters squared. And then finally, our surface area. Gotta add it all up. So we have our lateral area plus 2 times our base area. So 36 times 2 is 72. 72 plus 48, 120. Again, everything I did was in terms of pi. If you want to change these to decimals, which is what this page is actually asking for, just multiply it out by pi, 3.14. So again, 36 pi, that becomes 113. 48 pi will become 150.8. 113. And the last one, 120 times pi is 377. Any questions there? And again, you can do the same thing on each one of these. It's the same steps each time. Got number 6, base area. Lateral area. Surface area. Yeah, everything in meters squared. Again, I'm not going to do the other ones. I'll show the rest of those answers on tomorrow, but just give you an idea. If you hadn't finished this, make sure you finish it. Make sure you get it posted. Again, that's a better one assignment. And then for today's assignment, we're going to be doing volume. So let me go ahead and take this down. Yeah, volume is actually a little bit easier than surface area because we don't have quite as many steps to do. For both these shapes, our equation is essentially the same. It's the base area times the height of the side. So we just have to find base area, and then after we find that, multiply by the height, and we're done. So on here, again, doesn't matter the shape, whatever the shape is, you find your base area and then multiply by the height. Now, I know for a rectangular prism or a cube, you guys have done volume for those before, and you've probably done it as length times width times height, and that's fine. Length times width times height, that is a formula that works. Length times width is finding the area of the base, and then you're multiplying by the height. It's the same formula, it's just broken down and already has the length and width for the bottom part. So you're still finding the base area times the height. The only difference is this formula applies to any type of prism, not just a rectangular prism. So you're going to plug in any formula that you have for the base. So like on this one, you have a rectangle, whereas on this one, you have a trapezoid. They might even give you the area of the base though. Like on this one, they gave us the area of that trapezoidal base is 6.3. We didn't actually have to do a whole lot of work. We have a 6.3 already. All we got to do is multiply by the height. The height is the perpendicular distance between the two bases. Now, before I move on to actually showing examples here, I do want to show the other half of this, the cylinder. Because you'll notice on here we have our cylinder, which looks like a normal cylinder, but on this one it looks like it's slanted. This is what we call an oblique solid. We could have a right solid or we could have an oblique solid. And it does not matter if the figure is right or if it's oblique. Volume is a measurement that's telling us how much space an object takes up. As long as the figure has the same base and the same height, whether it's straight up and down or slanted, it's taking up the same amount of space. If you think of a stack of quarters, you stack the quarters straight up on top of each other, it's taking up a certain amount of space. You still have those same quarters, but you just offset them a little bit so that they're slanted. The volume hasn't changed, but it's the same quarters. Same thing here, right? This stack and that stack, if the dimensions were the same, would have the same volume, right? And there's a name for that. It's Cavalier's principle. So whether you have a right solid or an oblique solid, as long as they have the same base and the same height, they have the same volume. And just like our prism, our cylinder has the same equation. Base area times height. Now, they do already have the area of a circle formula plugged in because it's always a circle. But again, it's still base area times height. So it's the same formula. All right, let's go back to the other page. Let's do some examples. So down here on the bottom. The first one's really easy, so I'm going to skip that one. Let's come over to, let's do 3. All right. On 3, we have a special right triangle. We have a 90-degree angle, we have a 30-degree angle. They tell us that this piece is 12. Well, that's our hypotenuse, right? So if we know that the hypotenuse, is 12, we should be able to find the other pieces. That's the 30-degree angle. This is a 60-degree angle. The short leg is half of that. So that's 6. The long leg would then be the short leg times radical 3. We have all of our lengths. Now, in order to finish this, we just need the base area. So area of that base. And be 1/2 base times height of the triangle. 1/2 6 radical 3 6. 1/2 6 is 3. 3 times 6 is 18. 18 radical 3. We're going to take that. That's our base area. We need to find our volume. So all we need to do now is multiply that by 15, because again, 15 is our height. We have our base area. We have our height. Times 15, 270. Now, so 270 radical 3 is our answer as an exact value. Again, they did say, actually, they didn't specify it. I could leave my answer like this. Now, as far as units, when I do the base area, yeah, this is still in units squared. But as soon as I turn this into a volume, volume is a 3-dimensional measurement. It's how much space an object takes up. So now this should be in cubic units. So we have 279, I misread that, 270 radical 3, and this is in feet cubed. If you wanted to multiply this out, again, that's fine. You do times the square root of 3. So as a decimal, this answer would be 467.7 feet cubed. Now, Some of these other figures, we have slanted shapes. So these two are oblique rectangular prisms. It's still the same idea, but you might have to find some missing pieces. Just like we found missing piece on that one. Here we also have to, well, actually, I lied, we don't have to find missing piece on that one. So we have 12 is our height. These are the 2 dimensions for our base. Again, remember, height is always perpendicular with the bases. So it's not going to be the slanted line. It has to be perpendicular because it's between the bases. So on this one, base area, 10 by 15, 150. And for volume, base area times height, so we have 150 times the height of 12. That's it. Let's go over there to the other side real quick. All right, something I want to point out over here. So we have our oblique cylinder, right? This one is missing one of our values that we need. We need the height. Now down here they show they use Pythagorean theorem to solve for the height first before they plug it into our equation. Do we have to do Pythagorean theorem on that problem? No. Look at the sides. Here we have 5. This is 5. That was 13, so this is 13. So the missing side, 5, 12, 13. That's the other triple that I was talking about yesterday that comes up a lot. All right, so again, you might still have to use Pythagorean theorem on some of these problems, but a lot of times you're going to be using triples, if you remember. All right, let's go down to the bottom. So down here on the bottom, again, they're all cylinders. And whether you want to use your formula as base area times height or plug in the base area as your equation for area of a circle, either way is fine. Let's take a look at number 1 real fast. So again, usually I find base area first, which that's fine. On this one, the base is always the same. So they usually plug in our formula for area of the base and for big B, so that we're using that same formula every single time. Pi r squared times the height. So again, we have a radius, we have a height, we just have to plug them in. So pi 2 squared times 1. 2 squared is 4, 4 times 1 is 4, so I get 4 pi. And this is in feet cubed. Or it does say round to the nearest 10th, so 4 times pi is 12.6. Again, for our slanted figures, still the same thing. Identify your radius, identify your height, and just plug in. So we have, on the next one, pi, the radius is 1.5 squared, the height is 12. You don't have to write the equation every single time on these. It gets kind of repetitive. If you know what the equation is and you just plug it into it right away, that's fine. So we have 1.5 squared plus 12, in fact, times 12. That's 27 pi. And again, multiply that by pi, and brings to 84.8. Again, same idea each time on this. All right, you have 4 more problems left on that one. You have 4 more problems left on the other side. Make sure you get those done. Like I said, I did put two different spots up there for homework. There's one from yesterday, is its own assignment with yesterday's date. The one for today is up there with today's date as the first part of the title. Make sure you upload both pieces.